Okay, guys, so we're back now to talking about types of chemical reactions. Of course, this is section 2 of your book, and you are strongly urged to read this with all sections of your book. I am going to hit only the high points. So, not only do you have to be able to write chemical reactions and balance them, but you also have to recognize what type of chemical reaction is this and be able to tell me. So, first kind, synthesis. And up at the top of this page I have A plus X yields AX. This would be a synthesis reaction. A synthesis reaction is where you take two smaller substances, not necessarily elements, and combine them to make something bigger. I could take carbon dioxide and combine that with water and make sugars, which is what happens during photosynthesis. And that would be a synthesis reaction. Take two smaller things, make something much larger. And so here I have a series of examples with elements. And you'll notice again that we have O2 is always O2, not O for oxygen, unless it's in a product. And one reaction we were doing in lab was magnesium plus oxygen yields magnesium oxide. And we will make sure we finish that if we haven't already. And so here's just a series. You'll notice sulfur, when it's by itself, is typically not just S by itself, but S8, because that's how it's found in nature. So synthesis, two smaller things combined to make something bigger. Decomposition. Decomposition is where we take something bigger and break it down into smaller things. And so we could take water as a liquid and break that down into hydrogen and oxygen using electricity. Or we could take something like calcium hydroxide. Now we have 3 elements, and we can break that down not into elements, but into smaller, simpler compounds like calcium oxide and water as a gas. So we have a series of reactions here. They can generate either elements and or compounds or both. So decomposition, taking something larger and making smaller substances out of it. So single replacement. Single replacement is where I take either a cation as an element and replace the cation of a compound and make a new compound and a new element of that original cation. So A, here's an element, B is a cation, and I replace B with A, and I get my new element B. I can also do the same where I replace the anion in BX with Y, and so Y is an element, it replaces X, and we get BY plus X. And so I have some examples of both of those. The first 4 here, or 3, aluminum, sodium, and iron are all cations, and they will replace the cation in our substance over here. So we get sodium, we get lead by itself, it's kicked out the lead, and then aluminum is now with nitrate. So we get aluminum plus, and this is lead 2 nitrate, yields lead plus aluminum nitrate. In the next example, I replace one of my hydrogens in water with a sodium, so I get sodium plus water gives me sodium hydroxide plus hydrogen gas. Iron replaces one of the hydrogen, or both of the hydrogens in water, and I get iron 2 oxide, iron 3 oxide, and I get hydrogen. Magnesium will replace hydrogen and magnesium chloride, giving me hydrogen gas plus magnesium chloride. Here I'm replacing my cation, or my anion, with one halogen with another reactive halogen. And in this last case, you'll notice here I could replace chlorine with bromine in this compound with chlorine, and I got a reaction take place. But here, if I would try to replace chlorine with bromine, bromine is not as reactive as chlorine, and therefore no reaction will occur. And you'll get to figure out how those work. Double replacement. Now we have two couples. We have two compounds, and each are going to switch partners. So if A was with X to start with and B is with Y, then my product will have A with Y and X with B. Remember, however, I don't put X first because X is my anion. It has to be my cation and then my anion. So here we have potassium with iodine and lead with nitrate. When we go to our product, we get lead with iodine, lead to iodide, and then we're going to get potassium with nitrate. Remembering to put the cation first and the anion second. So you have to remember which things are positive, what things are negative, and we get two trade partners. So iron 2 sulfide plus hydrochloric acid yields hydrogen sulfide plus iron 2 chloride. We have hydrochloric acid plus sodium hydroxide yields sodium chloride plus H2O, or water. Double replacement. Both the cation and the anions are switched. Combustion reactions. Combustion reactions are when we burn something in oxygen. It can produce various substances. What you will see a lot of times will be a hydrocarbon, as in this second example. Propane plus oxygen gives us carbon dioxide and water. And in this case, I would not give you the products for this reaction. If I give you a hydrocarbon, I will give you the formula for the hydrocarbon. I wouldn't just say propane. I would say propane and then in parentheses C3H8. So you know how to write that formula. But then the rest you would have to figure out for yourself. And so you'd have to say, you know, it burns, that's your signal, put in oxygen. I won't necessarily say in oxygen. So if propane burns, what are the, write the chemical reaction for the burning of propane. And so you'd write C3H8 plus O2 yields CO2 plus H2O. We always get carbon dioxide in the burning of a hydrocarbon. Okay, so how can we figure out what's going on? Well, this is a nice little diagram. This is in your book. And it shows us kind of all of our different possibilities. And so let's look at a way of thinking through what kind of reaction this might be. So, first question you should ask yourself, is there only one reactant? If the answer is no, go on to question 2. If the answer is yes, however, you have to have a decomposition reaction. This means that you're going from something larger to two smaller substances. Question 2. Are the reactants two elements or two simple compounds? If the answer is no, you're going to go to step 3. If the answer is yes, you probably have a synthesis reaction. If both reactants are elements, the product is a binary compound. For metal reacting with a nonmetal, use the expected charges to predict the formulas of the compounds, just like you did in the last chapter. If the reactants are compounds, the product will be a single ternary compound according to the guidelines given earlier in the book. So you would have to look that up. The more you practice with this, the easier it gets. I know it sounds like a lot right now. So if our answer was no, that these are not two elements or two simple compounds, I'm ready to go to step 3. Step 3 says, are the reactants oxygen and a hydrocarbon? If the answer is no, you're going to go to step 4. If the answer is yes, you have a combustion reaction. And the products of a combustion reaction are always carbon dioxide and water. 4. Are the reactants an element in a compound with one other than a hydrocarbon? So do we have an element in a compound that's not a hydrocarbon? If the answer is no, go to step 5. If the answer is yes, you probably have a displacement reaction. You would use the activity series, which I have later in this PowerPoint, to determine the activities of the elements. If the more active element is already a part of the compound, no reaction will occur. Otherwise, the more reactive element will displace the less active element to form the new compound. And we'll go through several examples so that you're sure on how that works. 5. Are the reactants two compounds composed of ions? If the answer is no, start over. You've made a mistake. If the answer is yes, you probably have a double displacement reaction. Write the formulas for the possible products by forming two new compounds from the ions available. Determine if one of them is a solid, precipitate, or a gas, or a molecular compound such as water. And then use the rules that I'll give you to determine which ones will be insoluble as a solid. So I have another PowerPoint that goes through those rules as well as the activity series. So anyway, I think this about does it for this time, and I will talk to you in a bit. Bye.